Alright, so we've run dual regression, and after that's taken us time to run, we'll get an output of corrected p-threshold maps for every single component. So let's say we had 30 components. For each one of those, it's going to go into it, and it's going to estimate, does this thing pass correction for multiple comparisons, within that component, across space, testing across all these different voxels. So we can run a very brief command using fslstats to test each one of these individually. So I'm going to go into ICA.dr, the ICA.dual regression, which I just ran. Just heads up, this was a one sample test, okay? So it's not going to be too surprising that almost all of these things pass correction, because I'm merely just looking at resting states across all these different subjects. So all I need to do is type for each, and I'll just use subject as a placeholder. And I'm going to be using some wildcards to look at each one of these things individually. Okay, so these question marks just represent placeholders for any possible number. So it's going to loop through all 30 of these components. So TFCE, core P, T-stat, another question mark, just as a placeholder for that. And I'm going to echo the name of that subject, and also the output from fslstats showing the maximum at each one of these, okay, with this -r command. Now what they've done here, just for ease of convenience, is to do 1 minus p. So a higher number is going to be better. Anything that's above 95 is going to pass correction. Now I used a pretty lenient threshold. I used a 0.5 threshold when I was doing my group ICA analysis, so a lot of these things are going to pass. It's also a one sample t-test, so I have a lot of power that way as well. If I used a different matrix which took contrast between each of these, probably not a lot of these are going to pass correction. And if I use more stringent thresholds, like change my IC threshold to 0.9, then even fewer are going to pass as well. So in any case, that's how you determine the actual p-threshold, corrected p-value for each of these maps, and then you can go ahead and use that and say that these certain components either pass correction or they did not pass correction, and then the actual inference about what that means about these different networks or these different activation profiles, that's really up to you. So I hope this helped. That's how you do ICA in FSL, and I'll see you guys later.